within ductile, transparent materials like cords of plastic and glass. These transparent materials function as pipelines for light, and with their help, light, which usually moves in straight lines, can be sent along curved trajectories or around corners. Yet it was not until 1790s that the French Chap brothers invented the first optical telegraph. In the 1840s, physicists Daniel Coulomb and Jacques Babinet showed that light could be directed along jets of water for fountain displays. In 1854, John Tyndall, a British physicist, demonstrated that light could travel through a curved stream of water, thereby proving that light signal could be bent. Doctors Rode and Roos of Vienna used bent glass rods to illuminate body cavities in 1888. French engineer Henri Saint-René designed a system of bent glass rods for guiding light images, 7 years later in an early attempt at television. In 1898, American David Smith applied for a patent on a dental illuminator using a curved glass rod. In 1961, Elias Snitzer of American Optical published a theoretical description of a single-mode fibers whose core would be so small it could carry light with only one waveguide mode. Snitzer was able to demonstrate a laser direct through a thin glass fiber, which was sufficient for medical applications, but for communications applications the light loss became too great. In 1973, Bell Laboratories then developed a modified chemical vapor deposition process that heats chemical vapors and oxygen to form ultra-transparent glass that can be mass-produced into low-loss optical fiber. In 1991, De Surveyor and Payne demonstrate optical amplifiers that were built into fiber optic cable itself. The all-optic system could carry 100 times more information than a cable.
How can an optical fiber transmit light?
Light normally travels in straight lines, so for light to move along a winding fiber optic cable, it relies on a principle known as total internal reflection. This means that the light traveling along the fiber constantly reflects off the catling that covers it, which doesn't absorb any of the light. A light signal can travel a great distance but will degrade as it moves. How much the signal degrades depends on the wavelength of light and the purity of the fiber's glass.
If I take this laser beam and shine it into one end of my gelatin strip, the light would bounce around the jello and finally emerge at the other end. This is giving an example of how optic fiber works. A variety of industries, including the medical, military, telecommunication, industrial, data storage, networking, and broadcast industries, are able to apply and use fiber optic technology in a variety of applications.
And that was optical fiber.